Hello there. Today we're going to be dealing with binomial radical expressions. And I want to remind you that binomial means two. So two terms. So just want to remind you that that's what binomial means. But what's more important right now is to understand what it means to be like radicals. We know that when you're solving equations, you can combine like terms. Things like 5x and 2x are like terms because they have the same variable. In much the same way, we have what we call like radicals. And there are two conditions for you to have like radicals. The first is that they have to have the same index. Now remember, the index is the little number that is inside the little radical here. So in this case, the index is 2, the index is 2. We talked about how if it's not written explicitly, then you assume that it's a 2. And in this case, the radical, the index is 3 and 3. So they have to have the same index, and they have to have also the same radicand. So radicand, if you remember from the last section, is what is underneath the little house. So in this case, you have a 3 and a 3. So these two radicals are what we would call like radicals. And also here we have a 7 and a 7. They're both index of 3. So it doesn't matter that one's a 5 and one's a -2. These are considered like radicals. Then we have some examples of what's not a like radical. Even though you have the same index here, they're both 3, the radicand 2 and 5 are not the same. So these are not like radicals. So let's cross those out here. These are not like radicals. Also here you have the same index, 2 and 2, but again the radicand is different. And then of course, obviously, if you had something like the cubed root of 5 and the square root of 2, or even the square root of 5 for that matter, again the radicands both being 5, but the index 2, the index 3 not matching. So it has to satisfy both of those conditions. So once you have like radicals, then you can add and subtract them. You cannot add and subtract binomial radicals unless they are like radicals. So in this case it says add or subtract if possible. The reason why it says if possible is because it wouldn't be possible if they didn't have like radicals. So first, before we even get started, I can tell you for this one, we have an index of 3, radicand x, so it meets the criteria, so we can go ahead and add these. Well, look at example B, we have a square root and a square root, so that's the same index, but we have a radicand of 2 and a radicand of 3. So this is not possible. So we want to make sure that for B, we say that it's not possible. That's why it says if possible. And in this case, it's not possible. But it is possible for example A. And so how we do that is we basically look at the two terms, and it's kind of like factoring. You realize they both have the same radical, so if you factor the radical out, then you're left with a 5 minus a 3. And we know that 5 minus 3 is 2, and therefore this is 2 cubed root x. And even though the 5 minus 3 is on the right, it's okay to put the coefficient in the front of the radical. So for example A, the answer would be 2 cubed root of x. So now I'd like for you to try these examples on your own. All right, then the next example is what to do, how do you add and subtract radicals when they don't appear to be like radicand. For example, we do not have like radicals. These are all square roots. They all have an index of 2. And when you check for the second part, which is they all have to have the same radicand, you're looking at the 18, the 8, and the 72. Those are all different radicands. So technically, these are not like radicals. But it does say simplify before adding and subtracting. And so in this case, don't assume that just because it's not a like radical right away, that it won't be after you simplify. In this case, we have to simplify first, which means we have to break down the radicals. So we know that the square root of 18 is the square root of 9 times the square root of 2. We know that the square root of 8 is the square root of 4 times the square root of 2. And in the case of the 72, we know that the square root of 36 times the square root of 2 is 72. Last I checked anyway. So what you're seeing here is, this is the part that people don't necessarily like because they don't like having to break down radicals, but you're going to have to be able to do it. But what you see is that now that you do that, even before we finish simplifying it, you can already see that all of these have a square root of 2 in them. And that's going to be the like radical that we're talking about. We know the square root of 9 is just 3. We know the square root of 4 is 2, and the square root of 36 is 6. Okay? So the square root of 18 is the same thing as 3 root 2. But don't forget that you also have in front of the root 18 a 6. And we'll put it there for now. Then we're going to add, and you have a 4 in front of the root 8. And root 8, we've just realized that the square root of 8 is the same thing as 2 root 2. Then you have a minus, and you have a 3 in front of the root of 72. And the root of 72, we just learned, is 6 root 2. Okay? So now you can multiply the 6 and the 3, and that's 18 root 2. Then you can multiply 4 and 2 and get 8 root 2. And then 3 times 6, again, is negative 18 root 2. Now, as you look at the example, they all are like radicals because they all have the index of 2, and now the radicand is all 2 for all 3 of them. So now we can go ahead and add them like we did previously, and because there's a root 2 in all of them, you factor that out, and you get 18 plus 8 minus 18, and in that case, the 18 and the negative 18 cancel, and you're left with just 8. So your final answer is 8 root 2 for this example. So you see, something that might have started out looking like something that you couldn't simplify actually ends up being something that you can simplify. So now you will try this one here. Again, don't be fooled by the 50, 32, and 18. Break them down first and see if you can't find some like radicals there. Okay, now we're going to go on to multiplying. Multiplying, again, binomial expressions. Binomial meaning 2 terms. So you can see that what we've been doing so far has 2 terms. Even in the previous examples, you had 2 terms for each expression. So this is one expression, that's one expression, binomial, 2 terms, 2 terms. So what do we do when we're multiplying? Well, we're going to FOIL. FOIL is not something that is unheard of to us. We're going to go first times first, which is, let's do this in a different color here. We're going to go 3 times 2, and that's going to be 6. Then the O stands for outside, so we're going to go 3 times 4 root 5. And 3 times 4 root 5 is 12 root 5. So we're going to get plus 12 root 5. Notice how when you multiply the 3 times the 4 root 5, you multiply the 3 and the 4, but not 3 and the 5. So this is not 12 root 15. It's just the 3 times the coefficient of the 4, which is 12. And then we have our insides, which is a 2 root 5 and a 2. So 2 times 2 is 4. So we're going to get 4 root 5. And then lastly, we're going to get 2 root 5 times 4 root 5. And I don't know if you can see, but this looks like a little happy face. You've got some, eyes here, a nose, a mouth, the unibrow going on there. But anyway, so last times last is 2 root 5 times 4 root 5. So 2 times 4 will give you the 8. And then you have root 5 times root 5, which is root 5 squared. And we've already learned in a previous lesson that when you have a square and a square root, those will cancel. So really what you have here is 8 times 5, which is 40. Okay? You also can see over here that you have like radicals. You have square root, radicand 5, radicand 5. So 12 root 5 plus 4 root 5 will give you 16 roots of 5. So we've combined our like radicals here to 16 root 5. We had our plus 40 from there. And of course, we still have our 6. And our final answer, we want to combine like terms like before. So the 6 and the 40 can be combined to 46. And of course, plus the 16 root 5. And there is our final answer for this example. Alrighty then, 46 plus 16 over 5. So now you will try one on your own. I do want to give you a little bit of a hint here. I don't want you to get too scared. This is the same. You can either use the formula, if you remember from before, a minus b quantity squared was equal to a squared minus 2ab plus b squared, where in this case the a would equal root 2 and the b would equal root 3. Remember that we don't attach positive or negative to it. The formula will take care of it on its own. So you can use this formula, or you can do what we did earlier, which was the FOIL. Root 2 minus root 3 squared is the same thing as root 2 minus root 3 times itself, root 2 minus root 3. So you can choose to FOIL this, or you can use the formula to multiply this one. Just some hints for you. Okay, and then we have multiplying conjugates. All right, we've done conjugates in the past with imaginary numbers. So I just want to remind you that a conjugate is basically the same binomial, but a different sign in the middle. So this is a 2 plus root 3, so its conjugate is 2 minus root 3. Notice that the 2 doesn't change sign, just the middle number changes sign. Okay, so multiplying conjugates, it's not really done any differently. It's just a technique that we like to use for rationalizing, which is going to be our next example. But for now, I just want to show you how to do it. When you multiply conjugates, something really nice is going to happen. When you multiply conjugates, you're going to get rid of the radicals. For example, if you look at the previous answer that we did earlier here, when I got my final answer, I did not get rid of the square roots. It's still there. It's a root 5. So I did simplify it where this expression has 2 roots. The final answer only had 1, but it still had a radical. When you multiply conjugates, the good thing about that, if you do it correctly, and that's how you can know if you can check your work, if you will. When you're multiplying conjugates, you're supposed to end up with no radical. And I'm going to show you how that works. Again, we're using a formula here. So you will recall that when you have conjugates, a minus b, a plus b, the formula says to do a squared minus b squared. Okay? So I'm going to do this 2 ways. The long way is for you to FOIL. If you FOIL, which you really need to get past the FOILing thing, you only want to FOIL when absolutely necessary. And it's not necessary when you have conjugates. But I'm going to show you how it works either way. So with FOIL, you go first times first. So we're going to go 2 times 2 is 4. Outside times outside is going to be negative 2 root 3. And then inside times inside is going to be positive 2 root 3. And last times last is negative root 3 squared. So again, like before, when you have a square root and a square, that's going to cancel, leaving you with negative 3. And then what's going to happen with the like radicals here is that you're always going to get a negative and a positive, and they're going to cancel to 0. So in the end, all you have left is the 4 from up here minus the 3, and your answer is 1. Okay, so again, there's no more radical. The answer is 1. Now, if you were doing this with the formula over here, which is a lot easier, I would say that A is 2 in this case, and B is root 3. Again, paying attention to the fact that I'm not including a negative here, the formula itself will work it out. So in this case, A squared would be 2 squared minus root 3 squared, because that's what B is. Okay, so A squared minus B squared, and again, I would get 4 minus 3 because the square and the square would cancel, and I would still get 1 as my answer, and this is just a lot easier. But if you don't remember the formula, then you're going to have to do it the FOIL way. So I'm definitely encouraging you to use the formula for this problem. But here we go. You can try that one. And then why do we like conjugates? Conjugates are helpful for us. Oops, went too far. Because they allow us to rationalize. You remember that rationalize the denominator means that you don't want any square roots on the bottom. And so here I have a square root on the bottom. But I can't just multiply by root 5. If I multiplied by root 5 over root 5, which is what we did in the previous lesson, But in the previous lesson, you only had a monomial, one term. Now you have two terms. It doesn't work in this case because if I go root 5 times 1, I'm going to get root 5. And then if I go root 5 times root 5, I'm going to get root 5 squared. So it is true that this one will cancel, but I still have the root 5 minus 5 now. So there's still a radical there. So my point is that this is not going to work in the case of a binomial. So it's very important that you understand that you only want to do this when you're doing a binomial. Okay, when you have a binomial and you want to simplify or rationalize the denominator to get rid of this, like we just saw in the previous example, the only way to get rid of the square root when you have a binomial is to multiply by the conjugate. And obviously, we want to get rid of the radical on the bottom, so we won't necessarily get rid of it on the top, but we will get rid of it on the bottom, so we multiply by the conjugate of the bottom, which is 1 plus root 5. Okay? So, the first thing I'm going to do is multiply the top, and in the top, you're not going to have any nice formulas to use because these are not conjugates. So in this case, we are required to do the FOIL method. All right, so we're going to go ahead and do that. I'm going to go 3 times 1, which is 3. And then I'm going to go outside times outside, so it's going to be 3 and root 5. So that's plus 3 root 5. And then I'm going to do inside, which is 1 times root 5. So that's just going to be root 5. And then last times last is root 5 times root 5, which is plus root 5 squared on the top. Okay, so the root 5 squared is going to cancel. We've already talked about that. So I'll do that a little bit more. That's going to cancel. Here we're going to have like radicals. So 3 root 5 plus 1 root 5 is 4 roots of 5. Plus the 5 here, and of course you had a 3 in the beginning. And now I'm going to combine my 3 and my 5, and on top I'm going to have 8 plus 4 root 5 on the top. And I've yet to figure out what's on the bottom. So on the bottom, that's the part that we're actually rationalizing. So on the bottom, I'm going to use the formula. I know that I have a minus b, a plus b, so my a is going to be 1, and my b is going to be root 5. So according to the formula, I get a squared minus b squared, and the root 5 and the square cancel. So 1 squared is 1, minus 5. So 1 minus 5 is negative 4. So on the bottom of my fraction, I'm going to have negative 4. And my last step is just going to be to make sure that everything is reduced if possible. So, and what I mean by that is that you have now here 8 and 4 have something in common, and 4 and 4 have something in common. So in that case, I know that 4 goes into 4 once, goes into 4 once, goes into 8 twice. Okay? And there's a negative here. So I'm going to put the negative on the top part. So I'm going to have negative 2 minus root 5 as my final answer. Okay, now that won't always happen. Sometimes it doesn't reduce, and that's okay. But if it does reduce, then you want to make sure that you do that. So in this case, there was a negative on the bottom, so I moved the negative to the top, so that'd be a negative 2, and then a negative root 5. So there's my final answer, negative 2 minus root 5. And now you will try this one, and once you have completed that, you will have completed the lesson for today. So I will see you in class. Hi. Trying to find the off button here.